All right, guys, here we are ready for the next lesson. And today we're talking about the basics of trigonometry. And, a lot of times people think that the right triangle trig is the basics. And in a way it is, okay? But when you start talking about exact values or values of certain functions, it's going to come back to these things we're going to talk about today. All right, so the first group. All right, we're talking about the main graphs for the trig functions. Okay, so for the first one, all right, we're looking at this portion of the coordinate plane, all right, and we're going to split our x-axis into 4 equal parts. Now you got to use your imagination that they're equal because, yeah, it's off just a little bit. All right, so 0 degrees is at the y-axis, and we complete our graph at 360 degrees. All right, so halfway there is 180. Half of 180 is 90. And halfway between 180 and 360 is 270 degrees. All right, so our graphs go from -1 to +1. All right, and we're going to start out with the sine graph. All right, so the sine graph, sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360 is 0. All right, so when you connect these dots and you're drawing these graphs, there's a couple things that you need to remember. All right, the first thing is that it's a function, so it should pass the vertical line test. Right, and the other thing is that there's curves, they're not straight lines. Okay, so this is y equals sine x. Right, and if we're talking about radian mode, which is another way of measuring, it goes in place of those degrees, right? In radians, 0 is still 0. We talked about pi radians being equal to 180 degrees. So 90 is half of 180. So the radian measure for 90 degrees is pi over 2. Right? 360 is twice 270. So 360 degrees is 2 pi. Right? And zoom in a little bit because that's looking a little raggedy there. Right? And then 270 is 3 pi over 2. Okay, so we measure in both degrees and in radians. All right, so the next graph we're going to talk about is cosine x. All right, so for cosine, we talk about the same section of the coordinate plane, all right, and we split it in 4 sections just like we did. Let's see if I can do a little better at splitting those in half. Equal sections, not too bad. And the range is still -1 to 1. All right. Now, cosine looks a little different. That sine graph's a little rough, guys. They'll get better as we go along. All right. So cosine starts at 1. So cosine 0 is 1. Cosine 90 is 0. Cosine 180 is -1. Cosine 270 is 0. And cosine 360 is back up to 1. All right. So when we connect our dots, right, remembering number 1, it's a function. Number 2, it's a curve. All right. And then labeling the graph. So when it tells you to label your graph, you're going to be labeling the x and the y-axis. Okay. All All right, and then the third graph is a tangent graph. All right, so tangent graph also split into 4 sections. All right, but this time I don't worry about the y-axis labels. I'm going to put them in there, but they aren't as important. All right, so the tangent graph is asymptotic at 90 degrees. All right, so in the first quadrant, the tangent graph is positive. In the second quadrant, the tangent graph is negative. The third quadrant looks just like the first, which means that tangent is also asymptotic at 270. And the fourth quadrant looks just like the second. Okay, so the tangent graph starts over again, right, at 180 degrees. All right, so my labels, 0, pi over 2, pi, 3 pi over 2, and 2 pi, 0, 90, 180, 270, and 360. All right, now from these graphs, you could be asked a ton of questions. All right, so remember how I said that they're split into 4 sections, all right? Those are the 4 quadrants. So this graph is actually, this x-axis is the unit circle cut at the point 1, 0 and just kind of flattened out. So between 0 and 90 degrees, right, unit circle looks like this. Between 0 and 90, that's the first quadrant. Okay, between 90 degrees and 180, right, that's the second quadrant. Between 180 and 270, right, that's the third quadrant. And between 270 and 360 is the fourth quadrant. All right, so questions you could be asked. In the second quadrant, is sine positive or negative? Okay, so we're talking about sine. The second quadrant is between 90 and 180. All of the points, all the y values are above the x-axis. So in the second quadrant, sine is positive. All right. In the third quadrant, is cosine positive or negative? Okay. First, second, third, all the y values are below the x-axis, so cosine is negative in the third quadrant. Right? And another example, in the fourth quadrant, is tangent positive or negative? Right? Tangent, fourth quadrant, 2, 3, 4. The graph is below the x-axis, so tangent is negative. All right, so asking whether they're positive, whether they're negative, right? And another question that you could be asked is if the graph is increasing or decreasing. All right, so in the first quadrant, is cosine increasing or decreasing? All right, I say cosine or sine. I think I said cosine. All right. We'll pretend I said cosine if I didn't. All right. So in the first quadrant, the y value goes from 1 to 0. The graph's going down. As x goes up, y is coming down. So in the first quadrant, cosine is decreasing. All right. And in the third quadrant, what about sine? Is it increasing or decreasing? So sine, 1, 2, 3. All right. The y values go from 0 to negative 1. So sine is decreasing in the third quadrant. All right. Is the statement true? The function tangent x, f of x equals tangent x, is always increasing. As x gets bigger, y gets bigger. And the answer to that question is yes. Now, these arrows mess people up because look at that, that's going down. Okay, yeah, but it's going down to the left. All right, and there's the difference. All right, so some other questions that you may be asked. All right, what is the exact value of sine of 90? All right, sine of 90. So 90 degrees is the x. The y at 90 degrees for sine is 1. So sine of 90 is 1. All right. What is the exact value of cosine 270? Cosine 270, right? The y value is 0, so cosine 270 is 0. Right? And what is the exact value of tangent 90? At 90 degrees, the graph is asymptotic, right? There are no y values at 90, so at 90, tangent is undefined. All right, so 3 different things you could be asked besides just drawing the graphs. All right, so the second part of this basic trig, right, is the special triangles. There are 2 of them. Right, and for this, we need to remember SOHCAHTOA. Some old horse caught another horse taking oats away. All right, and there are 2, like I said, 2 special triangles. Right, the first one is the 30, 60, 90. All right, for the 30, 60, 90 right triangle, every 30, 60, 90, remember similar triangles, right, are the same shape, different size. So they're still going to have the 30, the 60, and the 90. It's just that the sides might be bigger. But for every 30, 60, 90 right triangle, the smallest leg is half the size of the hypotenuse. Right? The smallest leg is half the size of the hypotenuse. Right? So then in a right triangle, if you did a squared plus b squared equals c squared, right, you would get radical 3 for the length of the other leg. Okay, so then sine of 30 degrees. If they ask you for the exact value, the 30-degree angle is here. Sine is opposite over hypotenuse. So the opposite is 1 and the hypotenuse is 2. All right. Now, guys, when it says exact value, decimal answers are not accepted. So even if you just automatically think of 1/2 as being 0.5, don't write down 0.5, all right, because decimal answers won't give the full credit. Okay. All right. Tangent 60. 60-degree angle is here. Tangent is opposite over adjacent. So opposite is radical 3 over 1. All right. And then one other weird thing that comes up every once in a while is for tangent 30. So I'm looking at the 30-degree angle this time. Opposite over adjacent is 1 over radical 3. But they don't like us to leave the radical in the denominator. So we do what we call rationalize. We multiply it by the denominator over itself, right? A form of 1. It's not going to change the value. And then 1 times radical 3 is 3. Radical 3 times radical 3 is 3, right? Multiply what's under the radical. 3 times 3 is 9. Square root of 9 is 3. All right. So we don't leave a radical in the denominator. All right, so that's the first special triangle. All right, the second special triangle is the 45, 45, 90. All right, so if you remember back from geometry last year, if I have 2 angles that are the same, then the sides across from them are the same. All right, so you got to use your imagination because my artwork's not so hot. All right, so a squared plus b squared equals c squared tells us that the hypotenuse is radical 2. All right, so cosine 45. If you're asked to find the exact value, cosine is adjacent over hypotenuse. Now, it doesn't matter which 45-degree angle I use because I'm going to get the same result. So whichever one is fine. We'll use this one. Cosine is adjacent over hypotenuse. Right, and there we are again with that radical in the denominator. So we rationalize it, and we get radical 2 over 2. Okay. Sine of 45. Now, if you'll notice in these right triangles, I can't use the 90-degree angle because if I want the value of a 90-degree angle, I'm just going to use the graph. Right? So we're talking about the 30, the 45, and the 60 here. All right, so sine. Again, it doesn't matter which one I use. Sine is opposite over hypotenuse. All right, there's that 1 over radical 2 again, which we know is going to rationalize to radical 2 over 2. All right, and then tangent 45. Tangent is opposite over adjacent. Again, it doesn't matter which 45. Opposite over adjacent is 1. Okay, so we are not going to be working through as much trig as we usually do. Definitely not as much as I have in the past with the 11th grade math. But everything comes back to these special triangles or the graphs when we're talking about exact values. All right, so that's why it's called the basics of trig, because everything comes back to it. Okay, so on the next page, it says to draw the graphs of y equals sine x, y equals cosine x, and y equals tangent x. All right, I'm going to leave, we're going to need that, so better draw them. Right, even if you're copying this, you're still practicing it. Right, now guys, I always draw the points because it's important that you get in the right spot. And if you know where the right spot was just to be and your artwork is just off a little bit, right? This is an art class and I don't take off for art. All right, so that's y equals sine x, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, right next to it, we're going to draw a cosine. Zero, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so cosine starts at 1 and ends up back at 1 again. All right, so remember, it's a curve, it's a function, so no vertical lines, all right, and no straight lines. So there's a good example. I'm writing way off to the side farther than I usually do. So excuses, I know. I knew the point was supposed to go through there. My line missed a little bit. No big deal because I've got the point there. All right, so that one is y equals cosine x. All right, and then the third one is tangent. Zero, pi over 2, pi, 3 pi over 2, and 2 pi. All right, now tangent is asymptotic at 90. It's asymptotic at 270. Right? In the first quadrant, tangent is positive. So guys, look at all three of those graphs in the first quadrant. All three of them are positive. Okay. In the second quadrant, tangent is negative. Third quadrant looks just like the first. Fourth looks just like the second. Okay, so what we're going to do then is we're going to take those three graphs, right? We're going to answer these questions, find the values given. All right, so sine of 90. Sine of 90, 90 is pi over 2. The y value is 1. All right, not a lot of work to show. Drawing the graphs is your work. Sine of 180. At 180 degrees, the y value is 0. Sine of 270. 270 is 3 pi over 2. The y value is negative 1. Okay, cosine 90 is 0. I'll let you finish those out for your homework. Sorry, just checking to see what I had left for you. All right, tangent 90. 90 is pi over 2, so it's undefined. Okay. Cosine pi over 2. Pi over 2 is 90, right? So the y value is 0. Sine of 2 pi sine is 0. Right. So all these numbers, the answer should be either 0, -1, 1, or undefined. All right. So I'll let you finish those out for your homework. All right. And the last page, draw and label the two special triangles. All right. So the first one I'm going to draw is the 30, 60, 90. All right. So the smallest leg is always equal to 1/2 of the hypotenuse. And remember from geometry, the smallest leg is across from the smallest angle. All right. Hypotenuse is always the biggest. So that's across from the right angle. And the smallest side is across from the 30, not the 60. So then a squared plus b squared equals c squared. And radical form gets the other leg at radical 3. Okay, the 45, 45, 90 is an isosceles triangle. A squared plus b squared equals c squared has the hypotenuse at radical 2. All right, so remember we're going to use SOHCAHTOA. All right, and we already did sine of 30, so I'll do that again to remind you how that happens. All right, sine is opposite over hypotenuse. The 30-degree angle is here. Opposite is 1, hypotenuse is 2. Okay, cosine 45. Cosine is adjacent over hypotenuse. All right, 1 is adjacent to 45. Radical 2 is the hypotenuse. We rationalize it, which gives us radical 2 over 2. All right, and tangent 45. Tangent is opposite over adjacent. 1 over 1 equals 1. Okay, so again, your assignment is to just finish up these sheets and get those to me, and I will make sure that I get you credit. All right, guys, you have a good day. And there's going to be a weekly assignment for each of these weeks. All right, so just make sure you're looking for those as you go forward. All right, you guys have a good day, and we'll talk to you again next time you look at your assignments. All right, bye.